Okay, this video is part 2. It is doing a proof in congruence triangles. In order to prove triangles congruent, pretty much you need to tell me everything is congruent. So you must prove that the two triangles are congruent in every way. That would be angles, that would be sides. You need to have, if it's triangle to triangle, you need to have 3 pairs of congruent angles. You need to have 3 pairs of congruent sides. Then you can state that the triangles are congruent to each other. So what I want to talk about first, properties of congruent triangles hold true for like statements. If a triangle is congruent, it is going to be congruent to itself. That's the reflexive property. Symmetric property, you may switch the order in the statement. So triangle ABC is congruent to triangle DEF. Then triangle DEF is congruent to triangle ABC. So if we switch the order of our statements, then we may use the symmetric property. Transitive property, triangle ABC is congruent to triangle DEF, and DEF is also congruent to triangle JKL. Then we can cut out the middleman of triangle DEF and say triangle ABC is congruent to triangle JKL. So as using transitive property, just letting you know that it holds true for the congruent triangles for these 3 properties. What we're going to do is we're going to do this proof. So with this proof, I need to have pairs of congruent angles, congruent sides, and everything else. So what we would like to do is we would like to talk about some wonderful things. We have a given statement. So a given statement is going to be my first thing. So I have segment SV is congruent to segment RV. I have segment TV is congruent to segment WV. Oops, V, not Y. I have segment ST is congruent to segment RW. And I have angle T is congruent to angle W. That's all one. That is my given information. Given, not information, it's my given. So I'm going to make some markings on here so I don't lose track what I have. So SV is congruent to RV. TV, so TV is congruent to segment WV. Segment ST is congruent to segment RW. So ST is congruent to segment RW, and the order of the letters do matter. And angle, so let's use black. So angle T is congruent to angle W. So that's all my given information. So what I need to do is I need to find another 2 pairs of angles in order to prove, because I got all my side lengths. I have 3 pairs of side lengths that are congruent. I have 1 pair of angles. I need 2 more. So I need to find a pair of angles that work, that I don't have to get a bunch of information with. It is already a I did that I know and understand. So the things we know about angles are vertical angle congruence theorem or vertical angle theorem, and that's about all we got, because we don't know if lines are parallel or not. So with this, let's state that we have an angle V here, and I know that SVT, so starting at angle SVT, and if I start at S corresponds to R, so RVW. These are a pair of vertical angles. Now, vertical angles are always congruent, so I would just write that information down, and the only color I've not used is orange. So I know this angle and this angle are congruent. That is set information. So I'm going to write that down, okay? So step number 2, so we don't forget what I marked in, I'm going to write that in orange. Angle SVT, because I chose to start with S, you could start with T, it doesn't matter, but V has to be in the middle, is congruent SVT, so based on my statement, S corresponds to R, so it would be angle RVW, and that reason is the vertical angle, and I like to write down congruence theorem, just so I don't forget, but it's also vertical angle theorem, your choice. So now that I know these two pairs of angles are congruent to these two pairs of angles, I know angle S and angle R must be congruent. How do I know that? Well, coming back here, we talked about the third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. These two angles are congruent to these two angles, so angle S and angle R must be congruent. So, step number 3, angle S is congruent to angle R. And that would be the third angles theorem. Now that I have that, I had my 3 pairs of congruent sides. I have these two angles marked, and then I just proved that these two angles are congruent as well. So I have 3 pairs of my congruent angles, and I have my 3 pairs of congruent sides. So now I can state that triangle STV is congruent to triangle RWV. Now, the reason for that is a great question, and I remember it, but now it's slipped out of my tongue. It's proving all corresponding parts of congruent triangles are congruent. So I know this answer and I can't think of it, so let's go here and give me 2 seconds to pull out my book, because I know what I want to write down, but I can't recall off the top of my head. So I'm going to pull it from the book. I want to say it's a property of congruent triangles, but really my brain is not working today, so I apologize for this extra 35 seconds of me just rambling on to you. Correct. Definition of congruent figures. Well, I was totally off on what I was thinking. Definition of congruent figures. Definition of congruent figures is proving that all congruent parts are congruent. So, definition of congruent figures: prove all corresponding sides and angles are congruent. I apologize for my lack of remembrance on that, because I wanted to say it in a whole different way and just say corresponding parts of congruent triangles are congruent, but that's CPCTC and we're not there yet. Days 2's homework. Not too bad. It is 15 through 21 and 26. To let you know, it's on page 218. 15 through 21. You will have math. You will need to describe an error. You'll need to graph a triangle and then graph another triangle that's congruent. So make sure you preserve distances and that you preserve the angles. So definitely look at what you need to do for that. You can just do it based off slopes. 21, make sure you do the math to back it up. And then once again, 26 is a proof and you just got to fill in the missing parts. So the only true proof that you got is 26.